Okay, so what we're going to start talking about this week is a sequence and series. So let's talk about, we're going to talk about a recursive sequence first. All right, so take a look at these are called sequences here. I'll tell you what that is in a minute. It does say, though, to determine the next three numbers. So I'm actually going to do these two here first, and then I'll go back to this one. These two are easier. So notice I have 7, 10, 13, 16. So the next number, you have to figure out what is the pattern. And the pattern is, hopefully you came up with, that the pattern is we are adding 3. So the next number would be 19, and then 22, and then 25. All right, so let's take a look at this one here. So my first number here is 3, 6, 12. So notice I'm not adding, because between 3 and 6, that's an add of 3. And between 6 and 12, that's adding 6. So since that number is changing, it's not adding a number. So what else could we be doing? We are actually multiplying by 2. So 2 times 3 is 6. 6 times 2 is 12. So then the next number would be 12 times 2 is 24. And then 24 times 2 would be 48. And then 48 times 2 would be 96. So this is a multiply by 2. All right, so let's take a look at actually the first one. I have 1, 2, 1, 1, 2, 3, 5, 8. So what would the next number be? So think about it. So hopefully you notice that to get the next number, notice here 1 plus 1 is 2. And then 1 plus 2 is 3. And 2 plus 3 is 5. 3 plus 5 is 8. So then to get the next number, I would add 5 plus 8. And that would be 13. To get the next number, I would add 8 plus 13. And 8 plus 13 would be 21. And then to get the next number, I would add 13 and 21 and get 34, sorry. All right, so you might have heard of this. This is called the Fibonacci sequence. Fibonacci sequence. And the reason why you might have heard of it is because you actually find this sequence produced a lot in nature. So that's why it's a famous sequence. So you might have heard of it, maybe not, but if you haven't heard of it, now you've heard of it. All right, so let's take a look at some terminology here. We have a sequence is an ordered pair, a sequence is an ordered list of numbers. Each number in the list is called a term of the sequence. So let's just say I have this sequence here. Let's say I have 2, 4, 6, 8, and so on. Okay, it keeps going. And what you need to know is that this 2 and 4 and 6 and 8, those are all called terms. And we would label this as A sub 1. 4 would be A sub 2. 6 would be A sub 3. Now, where am I getting the 1, the 2, and the 3? Because we would call this A sub 1 because 2 is in the first position. It's my first term. The next one would be A sub 2 because 4 is the second term. The next one's A sub 3 because 6 is the second term. So 8 would be A sub 4. So now what if I ask you, what is the 8th term? So what I'm asking for is, what is A sub 8? All right, so we can continue this sequence. All right, so my next number would be 10, and then 12, 14, 16. So this would be A sub 1, 2, 3, 4. This would be A sub 5, A sub 6, A sub 7, A sub 8 is equal to 16. All right, so let's take a look at what a series is. A series is the expression formed by adding the terms of a sequence. So let's say I have this sequence, and this is going to be a sequence that stopped. 2, 4, 6, 8, stop. So a series would be taking my terms and adding them up. 2 plus 4 plus 6 plus 8. Okay, which is equal to 20. All right, the next thing is a recursive sequence. All right, relates a term in the sequence to the term before it. That was the Fibonacci sequence. The Fibonacci sequence is a recursive sequence. No set formula to find any term. Recursive formulas start with the value of the initial term, which is usually identified as the first term, indexed by the term number 1, which I just told you about, right? A sub 1, so negative 2 would be my first term. The 12th term would be written as a sub 12, kind of like what I told you over here. A sub 8 would be the 8th term. All right, so let's say, let me just move this up. Sorry. Okay, so let me show you an example of a recursive sequence. So I'll use this here as my first term. So a sub 1 is equal to negative 2. So let's say I have this formula. A sub n is equal to 4 times a sub n minus 1. Now, the giveaway that this is a recursive sequence is this here, this n minus 1. When you see n minus 1, they're talking about a recursive sequence. All right, so I'm looking for, let's say, the next 3 terms. So we'll just actually do the next 2 terms. Find the next 2 terms. All right, so I already have a sub 1. My next term would be a sub 2. So notice what changed from here to here is my n changed to 2. So what I'm saying here, that n is equal to 2. So I have 4 times a sub, what's my n? My n is 2, minus 1. Equals 4 times a sub, well, what's 2 minus 1 here? 2 minus 1 is 1. Equals 4 times, well, what's a sub 1? A sub 1, remember, is equal to negative 2. So I plug in negative 2 here, so I get negative 8. All right, now let's do the next term. A sub 3. So now my n is 3. So now n equals 3. So I have 4 times a sub 3 minus 1. Equals 4 times a sub, well, 3 minus 1 is 2. So it's 4 times, what's a sub 2? So look at the term before. A sub 2 was equal to negative 8. So it's 4 times negative 8, which is negative 32. Okay, so that's what a recursive sequence is. It uses the term to get to your next term. All right, and the last thing is an explicit. To be able to find any term in a sequence without knowing any other terms. So I'm going to just move this stuff up again. Okay, so explicit. To be able to find any term in a sequence without knowing any other terms. So let's talk about an arithmetic sequence. We will talk about arithmetic and geometric some more another day. Actually, the next tomorrow will be arithmetic and then geometric. All right, so arithmetic means the difference between consecutive terms is constant, called a common difference. That was what I did up here. So look on your paper. To go from one term to the next term, I added a constant of 2. That's an arithmetic sequence. A geometric sequence is the ratio between consecutive terms is constant, called the common ratio D. This is common difference D, common ratio R. All right, so that means to go from one term to the next term, we're multiplying by a fixed number. All right, so for instance, let's just write this down. Arithmetic. Okay, let's say I have these numbers here, this sequence. 5, 10, 15, 20, 25, and so on. This is arithmetic. To figure out what the common difference is, you take 2 consecutive terms. It has to be consecutive, okay? And you subtract them. It has to be a sub 2 minus a sub 1. You have to take the number after and subtract the number that's in front. So it'd be 10 minus 5, which is equal to 5. So what I'm doing, that's called my common difference. Okay, that's D. So D is equal to 5. That's what I'm adding to go from one term to the next term to the next term. All right, geometric would be like this. So let's say I have this sequence here. 2, 4, 8, 16, 32, and so on. So notice what I do is to find the common ratio, I take two consecutive terms and I divide them. Now it has to be the second term minus the first term, the one in back divided by the one in front. So it would be a sub 2 divided by a sub 1. So it would be 4 divided by 2, which is equal to 2. This is called your common ratio. So R is equal to 2. That means I'm multiplying by 2. Okay, so you have to flip the page so we can go on to a couple problems. Okay, so the first one says find the next three terms. So notice that I have this subscript. Look at what the subscript is. It's n minus 1. That means it is recursive. So I have the first term. It's t sub 1 is equal to 8. So my next term is going to be t sub 2. So now my n is equal to 2. So it's t sub 2 minus 1 minus 4, which is going to be t sub 1, because 2 minus 1 is 1, minus 4. What is t sub 1? T sub 1 is equal to 8. So it's 8 minus 4, which is equal to 4. All right, now I want t sub 3. Now n is 3. T sub 3 minus 1 minus 4. So that's t sub 2, because 3 minus 1 is 2, minus 4. T sub 2 is equal to 4, right? T sub 2 equals 4. So that's going to be 4 minus 4, which is equal to 0. All right, so I need one more term. T sub 4. Now n is 4. So it's t sub 4 minus 1 minus 4 equals t sub 3 minus 4, right? Because I did n, 4 minus 1 is 3. So t sub 3 is equal to 0. So that's 0 minus 4, which is equal to negative 4. So those are the next three terms. If it asks you to write the sequence, you would have to start with 8, comma, 4, comma, 0, comma, negative 4. That's actually right in the sequence. All right, next one. It says determine if it's recursive and then explain. Okay, so number 2 says t sub n equals 4n plus 3. Is this recursive? And the answer is no. And how do we know? Because there is no n minus 1 as a subscript. All right, let's look at the next one. We have t sub 1 equals negative 4. T sub n equals 3 times t sub n minus 1. Remember I said if you see n minus 1, that means it is recursive. So this is yes, because there is a subscript of n minus 1. All right, and the last one, t sub 1 equals 0. T sub n equals 2 times t sub n minus 1 squared. This is recursive, yes. And same thing, because there is a subscript of n minus 1. Okay, and let's take a look at the word problem. Okay, so the population of a city increases by 4% each year. So this should be familiar because this is exponential growth, right? Something's increasing. The first year the population is 80,000. Write a recursive formula for the population on the city at the beginning of the nth year. All right, so remember our population would be y equals 80,000, that's the initial value, times 1 plus the rate, which is 0.04, raised to the t power, which is y equals 80,000 times 1.04 to the t power. Now, 80,000 is my initial value. So that's my a sub 1. So a sub 1 equals 80,000. Now I'm going to write my formula. So it's going to be a sub n equals, in here is what's going to change. And I'm still going to keep this, 1.04 raised to the t power. So I need this number in here to be 80,000 to start off. So this is going to be a sub n minus 1. Okay, so that's it, and have a good night.